Basic of truth table. So a truth table is a breakdown of all the possible truth values returned by a logical expression. A truth value is typically either true or false, or 1 or 0. In some cases, the value might be based on another binary system, such as on and off or open and closed, but these are not as common. Truth tables are used in Boolean algebra and in other areas of mathematics and science that rely on Boolean logic to show the possible outcomes of an expression or operation in terms of its truth or falseness. A logical expression includes one or more Boolean functions that determine the logic used in calculating the expression's truth or falseness. The most common Boolean functions are and, or, and not, which are described in the table. Type logical conjunction, logical inclusive disjunction, logical negation. Logic evaluates the true if both statements are true. Evaluates the true if one or both statements are true. Evaluates to true when the statement is false and evaluates to false when the statement is true. Symbols used to represent the functions and calculations. Ascending wedge, asterisk, and dot. Descending wedge, plus sign, and vertical bar. Dash with tail preceding statement, tilde preceding statement. So Boolean function can be used in any combination to define an expression's intended logic. The functions follow their own rules of precedence. The not function takes precedence over the other functions, which means it is evaluated first. The and function takes precedence over the or function. Parentheses can be used to override the rules of precedence to better control the expression's logic, as calculations within the parentheses are evaluated first. Consider the expression a and b. The expression used the and Boolean function to connect the variables a and b. The possible outcomes from this expression can be mapped out in a truth table. The truth table would include a column for each variable, a column for the outcome, and a row for each possible value combination. In the following truth table, the letter T represents true or 1 and the letter F represents false or 0. So as you can see, the expression has 4 possible truth value combinations. The first row of values after the heading shows a value of true for each variable. The final column highlighted in blue also shows a true value. This means that the expression returns true when both variables are true. However, the subsequent rows indicate that the expression returns false for all other value combinations. In other words, if only one variable is true or neither of them is true, the expression evaluates to false. This is because the expression includes the AND operator, which states that both statements must be true for the expression to evaluate to true. Not surprisingly, the changing the expression Boolean functions affects the results. For example, the expression a or b uses the OR function to connect the two variables. Although there are still only 4 possible value combinations, the results are much different, as shown in the following truth table. Now the expression evaluates to false only if both a and b are false. So like for example, as you can see in the table, in the first column, which is in the letter A, there are true, true, false, false, and the second column, true, false, true, false. So in the third column, in the third column, A or B, which is highlighted in blue, true, 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 false. You can also use both truth tables when working with the NOT operator. For example, the expressions not A specifies the logical negation of A because there is only one variable. The truth table requires only one column for that variable, along with the outcome column. So that as you can see, the table requires only 2 value rows because there are only 2 possible values, true and false. Because the not operator is used, the expression returns false if A is true and returns true if A is false.
Good day, everyone. I am Rosemary Ella Barria. My assigned topic is all about understanding tautologies. So, what is a tautology? A tautology is a compound proposition which is always true. Always remember, a tautology is always true. To understand tautologies, I will give one example. I am considering one proposition called P. Now we know that there are two possible truth values of this particular proposition, that is true or false. The second one is not P would be false true. As we know, not P means that whenever P is the true, then not P will be false, and whenever P is false, then not P will be true. Here, I'm considering the compound proposition P, not P. Now, what is the output of this compound proposition? Disjunction means that whenever we have one true value, then the result would always be true. So, for this particular combination, the result is true, and for this one also, the result is true, and hence, this compound proposition is always true. Therefore, we can say that compound proposition is a tautology because it always results the truth value.
So today I'm going to discuss the logical connectives and operation. What are logical connectives? So logical connectives are symbols or words that use to join statements together. So it is important they help us form complex statements, understand their truth or falsehood. So I put here 5 examples of basic logical connectives. So first we have AND with its symbol, and the operation it combines two statements where both need to be true for the result to be true. For example, it is raining and it is cold. It means both conditions must be true. So here an example of truth table. So in truth table, P represent a propositional variable or statement. So a propositional variable can be any statement that is either true or false. For example, P could represent the statement it is raining and Q represent the statement it is true. So both need to be true to get the result true. Next we have OR with a symbol. So operation combines two statements where at least one needs to be true for the result to be true. For example, it is raining or it is cold means one or both condition can be true. So I have here an example of truth table. So we only need one statement to be true. So it is very different to the AND because AND need two statements to get the result true. So the third one, we have the NOT with a symbol of, and the operation reverses the truth value of the statement. For example, it is not raining means it is true that is raining. We need to reverse truth value of statement, then it becomes false. So the fourth one, we have implies with a symbol. An operation, it indicates that the first statement is true, then the second one must be true. For example, if it is raining, then it is cold. So for here, I give her a truth tables example, where P represent the first statement, it is raining, and Q represent the second statement, then it is cold. So first statement is true, then the second statement must be true to get the result true. The last one, we have if and only if. So symbol, so the operation is biconditional. So both statements must be either true or false. So let's proceed to logical operation in practice. So first we have use in proofs and problem solving. For example, proving mathematical theorems using logical implications. Implications, equivalences. So second, we have computer science. Basis for algorithms, programming, and circuit design. Example, conditional statement in programming language, if-else statements. So the third one, we have philosophy. Analyzing arguments and reasoning. For example, evaluating the validity of philosophical arguments. And the fourth one, we have everyday reasoning, making decisions and solving problems in our daily life. For example, if we study, then we will pass the exam.
The conditional statement and truth table. In the truth table provided for the if-then statement, the column represents P, the hypothesis, which in this case represents the statement if you study 4 hours or more. Q, the conclusion, which in this case represents the statement you will score an A on the exam. P, if then Q, the conditional statement which is true when the hypothesis implies the conclusion. The truth table shows the different combinations of truth values for P, Q, and P if then Q. When both P and Q are true, the conditional statement P if then Q is true. This means if you study 4 hours or more, you will come an A on the exam. When P is true and Q is false, the conditional statement P if then Q is false. This indicates a situation where you study 4 hours or more, but you did not score an A on the exam. Since P is false, you did not study 4 hours or more, and Q is true, you scored an A on the exam. It indicates that regardless of the whether you studied 4 hours or more, you still achieved the desired outcome of scoring an A on the exam. Therefore, in this case, the conditional statement P if then Q is true. When both P and Q are false, the conditional statement P if then Q is true. This implies that if you did not study 4 hours or more, it does not affect your ability to score an A on the exam. That's all.
Contradictions and contingencies delve into the intricate dance between conflicting statements and unforeseen events, offering a rich field of study that spans logic, philosophy, and decision theory. Exploring contradictions reveals the paradox and puzzles that challenge our understanding, such the famous liar paradox, where a statement refers to itself in a way that creates a logical loop. On the other hand, contingencies emphasize the importance of flexibility and adaptation, teaching us how to prepare for and react to unexpected changes in various contexts, from everyday life to strategic business planning. Imagine unraveling the complexity of what can and cannot coexist, or learning how to navigate through unpredictable situations. So I have examples about the contradiction and contingency. So here are my examples.
Tables in digital electronics is crucial for designing and implementing logical functions accurately. They provide a systematic method for determining the output. The output values based on the given input values. By examining the truth tables, engineers can identify patterns, relationship, and independent.
What is truth table? A truth table is a math table that helps you to figure out if a complex statement is true or false. In a truth table, each statement is usually represented by a letter or a variable like P, Q, or R. And each statement also has its own column in the table that lists all of the possible truth values. So we have here the steps on how to solve the truth table, and also we have here examples of it.